Hello, mathematicians. Today we're going to be learning about fractions and decimals, and more specifically, converting improper fractions to decimals. Now, improper fractions are when the numerator is larger than the denominator. So that means that this value, if it's an improper fraction, is going to be greater than 1. Because here, when we have a fraction, we're actually dividing the numerator divided by the denominator. And if the numerator is bigger, then we're going to have a value that's greater than 1. So here, our dividend is our numerator, and our divisor is our denominator. And we ask ourselves, how many times does 2 go into 7? Well, 2 goes into 7 3 times because 2 times 3 is equal to 6. And so we're going to write the 6 here and then subtract. 7 minus 6 is equal to 1. So because we have a remainder here, we're going to go ahead and add a decimal point after the 7. Make sure we bring it up and add a 0 after that decimal point, which we will then bring down. Then we ask ourselves, how many times does 2 go into 10? So 2 goes into 10 5 times because 2 times 5 is equal to 10. And then we're going to go ahead and subtract. So 10 minus 10 is equal to 0. And now we have no remainder. So that means that 7 over 2 is equal to 3 5/10. So let's do another example. We have 9 over 8, which can be written as 9 divided by 8, where our numerator is our dividend and our denominator is our divisor. Then we ask ourselves, how many times does 8 go into 9? Well, 8 goes into 9 one whole time, and that's because 8 times 1 is equal to 8. Then we write an 8 there, and we subtract. 9 minus 8 is equal to 1. Because we still have a remainder, we're going to add a decimal point here and a 0. Make sure you bring up the decimal point to ensure our final value is correct, and bring down the 0. Then we ask ourselves, how many times does 8 go into 10? Well, 8 goes into 10 one time, and that's because 8 times 1 is equal to 8. Put an 8 down there, and then we subtract. So 10 minus 8 is equal to 2. Now, we still have a remainder, so let's add another 0 and see what happens. We bring it down, and so we have 20, and we ask ourselves, how many times does 8 go into 20? Well, 8 goes into 20 2 times because 8 times 2 is equal to 16. So we add the 16 on the bottom, and then we subtract. 20 minus 16 is equal to 4. So we're going to add the 4 on the bottom, and then add another 0 because we still have a remainder. Usually we like going 3 digits after the decimal point, and then once we're at 3 digits, we just approximate. So let's see what happens when we bring the 0 down. So we have 40. So we ask ourselves, how many times does 8 go into 40? Well, 8 goes into 40 5 times, and that's because 8 times 5 is equal to 40. So we take the two 40s and we subtract, and we have no remainder now. So 9 over 8 is equal to 1 and 125 thousandths. All right, so here we have another example where we have 14 over 3. And again, we're going to write this as a division problem, which is 14 divided by 3, where our numerator is our dividend and our denominator is our divisor. Then we ask ourselves, how many times does 3 go into 14? Well, 3 goes into 14 4 times, and that's because 3 times 4 is equal to 12. So we put a 12 down here, and then we subtract. 14 minus 12 is equal to 2. Since we have a remainder, we're going to add a decimal point and a 0, bring up that decimal point, and bring down that 0. And then we're going to ask ourselves, how many times does 3 go into 20? Well, 3 goes into 20 6 times because 3 times 6 is equal to 18. So we put the 18 on the bottom, and then we subtract. 20 minus 18 is 2. So let's add another 0 since we still have a remainder. And we get 20 again. So 3 goes into 20 6 times because 3 times 6 is equal to 18. Add an 18 and subtract. Notice how we get a remainder of 2. And if we were to add another 0 and bring it down, we would get 20 again. So 3 goes into 20 6 times because 3 times 6 is equal to 18. And this keeps repeating. So our answer is actually 4.6 with a line on top showing that this 6 keeps repeating on and on and on forever. So 14 over 3 is equal to 4.6 with a line on top showing that the 6 keeps repeating on and on. Alright, so here we have 15 over 11. So remember that this is a division problem where we have 15 divided by 11. 15 goes on the inside because our numerator is our dividend and our denominator is our divisor, which is 11. Then we ask ourselves, how many times does 11 go into 15? Well, 11 goes into 15 one time because 11 times 1 is equal to 11. Then we add an 11 and we subtract. 15 minus 11 is equal to 4. So because we have a remainder, we're going to add a decimal point and a 0 and bring up that decimal point and bring down that 0. Then we ask ourselves, how many times does 11 go into 40? Well, 11 goes into 40 3 times because 11 times 3 is equal to 33. So we add 33 and then we subtract. Then we have a 7. So we add another 0 and bring that down. Then we ask ourselves, how many times does 11 go into 70? Well, 11 goes into 76 times because 11 times 6 is equal to 66. And then we go ahead and subtract, and we get a 4. And then we add a 0, bring it down, and we get a 40. Okay? So earlier, we also did get a 40. And we know that 11 goes into 40 3 times because 11 times 3 is equal to 33. And then we subtract. Now we get a 7. If we were to add another 0, we would get a 70, and then we would get a 4, which would be 40, and so on. So notice that there's a pattern here. It goes 1.363636, and it keeps going. So our answer is 1.36 with a line on top showing that the 3 and the 6 keep repeating. So 15 over 11 is 1.36 with a line on top of the 36 showing that it keeps repeating. And that's it for converting improper fractions to decimals.